That shape rolling down the highway right now is solving 5 engineering problems simultaneously, and it's been doing it for a century. Most people never notice, because it works too well to draw attention to itself. Every day you drive past tanker trucks moving fuel, milk, chemicals, liquid food carrying thousands of gallons at highway speed. And almost every single one shares the same basic shape, a cylinder. You've probably never questioned that. But that shape isn't default. It isn't accidental. And it definitely isn't aesthetic. It's the answer to 5 problems that destroyed equipment and cost the industry millions before engineers finally understood what shape actually works. Those 5 problems: pressure, liquid surge, center of gravity, weight, and cleanability. Let's go through exactly why the cylinder solves all of them. When you fill any container with liquid, that liquid pushes outward constantly in every direction. Now multiply that by 6,000 gallons. Here's the real-world consequence first. A flat-walled tank at that scale will fail. Not slowly. Not gracefully. The pressure concentrates at corners and seams until the structure gives way. Engineers learned this the hard way with burst tanks, spilled cargo, and expensive rebuilds. The fix was the curved surface. When a tank is round, the pressure doesn't pile up at weak points. It spreads continuously around the entire shape. The cylinder shares the load instead of fighting it in one spot. Think of it this way. Imagine pressing your palm flat against a wall versus pressing your fist against it. The flat palm distributes force across a wide surface. The fist concentrates it at a single point. A flat-walled tank is the fist. The cylinder is the palm. Same force. Completely different outcome. Significantly less steel. And less steel means more cargo. Every kilogram removed from the tank structure is a kilogram the truck can legally carry instead. For a company running hundreds of tankers every day, those gains compound into serious operational savings over a year. The same logic shows up in submarine hulls, industrial storage tanks, and high-pressure gas pipelines. Different industries. Different scales. Same conclusion: curved shapes handle internal pressure more efficiently than flat ones. Physics doesn't care what industry you're in. The pressure problem is actually the easier one to solve. The harder problem is movement. Picture a bucket half filled with water. You break into a run, the water surges forward, crashes back, sloshes sideways. Now scale that to 4,000 gallons traveling at 60 miles per hour. This is called liquid surge. And it's more dangerous than most people realize. When the driver brakes, the liquid wants to keep moving forward. When the truck corners, the liquid wants to continue straight. That moving mass doesn't sit passively, it actively pushes against the vehicle, fighting every directional change the driver makes. Here's what most people completely misunderstand about tanker trucks. The truck isn't just carrying the liquid. The liquid is trying to steer the truck. A passenger shifting in a seat barely affects a vehicle. Several thousand gallons shifting at highway speed is a fundamentally different situation. The driver turns right. The liquid pushes left. The driver brakes. The liquid keeps going forward. The driver accelerates. The liquid falls behind and pulls back. Every single maneuver creates a force response the driver has to consciously work against. That's not a driving challenge. That's a physics battle happening inside the tank on every trip. A round cross-section helps manage this. The curved interior gives those forces a shape they can distribute around, rather than a flat wall to slam into and reflect off unpredictably. Most tankers also run internal baffles, physical dividers that slow and break up the surge. But those baffles only work well because the cylindrical shape gives them the right geometry to function within. A different tank shape and the baffles become far less effective. Remove the cylinder. The forces don't disappear, they concentrate. And here's the part that surprises most people. A partially filled tank is actually more dangerous than a full one. Less liquid sounds like less risk. But less liquid means more room, and more room means more momentum. The liquid has space to build up speed before it hits the tank wall. That translates to stronger surge forces, more instability, and a much harder driving challenge. This is why load management isn't just about weight limits. It's about how much room the cargo has to move. Tanker trucks are already at a disadvantage when it comes to stability. They're tall, the load sits high, and a liquid load that shifts mid-corner directly raises rollover probability. This is why tanker drivers require specialist certification that standard commercial drivers don't need. They're not just managing a large vehicle. They're managing cargo that moves independently and moves in ways that work against them. Their braking distances change depending on how full the tank is. Their cornering behavior changes mid-corner as liquid shifts toward the outside. Even lane changes at highway speed require additional planning that a flatbed driver simply doesn't need to think about. A driver hauling steel beams knows exactly where every kilogram of cargo is at every moment. A tanker driver is constantly compensating for cargo that is still reacting to the last thing the truck did. That's a fundamentally different driving challenge. And it's one that the shape of the tank either helps or makes worse. The cylindrical shape combined with careful weight distribution and internal baffles is part of what keeps that challenge manageable within safe limits. Change the shape, and the stability equation changes with it in ways that are hard to predict and harder to control. Rollover investigations frequently examine load level, liquid movement, and tank geometry together because the shape of the container isn't just holding cargo. It's actively contributing to whether the vehicle stays upright at highway speed. This one connects back to pressure, but it deserves its own moment, because the economic consequences are significant. A flat-walled tank strong enough to hold thousands of gallons of pressurized liquid under road load requires substantial additional steel, structural reinforcement at every corner, thicker walls at every seam, extra bracing wherever stress wants to concentrate. The cylinder distributes stress so efficiently across its entire surface that it achieves the same structural strength with far less material. In freight, weight is money and it's a hard limit. Legal payload limits don't increase because your tank is heavy. Every extra kilogram of tank structure is a kilogram of cargo you legally cannot carry on that run. Across a single truck, the difference might be a few hundred kilograms. Across a fleet of 200 tankers running daily loads across a year, that difference becomes a staggering amount of lost cargo capacity. The round shape isn't just structurally elegant. It's the economically rational choice, and the industry figured that out through direct financial experience, not theory. Many tankers don't carry the same product on every run. Food-grade liquid one trip, a different regulated product the next. And between every run, the tank has to be cleaned completely, verifiably to a documented regulatory standard. This sounds simple. It is not. A square tank has corners. Corners trap liquid. Residue settles into angles that are awkward to reach with cleaning equipment. Bacteria can establish in recessed areas that are difficult to inspect visually and harder to clean chemically. In regulated transport, dairy, pharmaceuticals, food-grade chemicals, a tank that can't be cleaned completely is a tank that cannot be used legally. A round interior has almost no dead zones. The cleaning path is continuous and uninterrupted. Spray heads mounted inside the tank can reach the entire interior surface without repositioning. Residue has nowhere to hide, nowhere to settle, and nowhere to be missed by an inspector. Cleaning cycle time drops. Turnaround between loads improves. For a fleet operator running tight schedules across multiple product types, that operational efficiency compounds into real savings across the year. For regulated industries, cleanability isn't a secondary benefit of the round shape. In many cases, it's the primary design requirement that the rest of the tank geometry has to accommodate. Not every tanker is a perfect circle, by the way. Some use elliptical cross sections. Others use modified profiles to stay within legal road height limits. Some operators run lower, wider tanks to bring the center of gravity down at the cost of some volume. Others prioritize maximum cargo capacity and accept a slightly higher center of gravity with additional driver training to compensate. Because engineering is always a negotiation between competing priorities. There is rarely one perfect answer, there are only trade-offs. And the job is to find the best available balance for each specific set of constraints. The cylinder dominates because it wins that trade-off calculation for the widest range of applications. When specific operating conditions shift those trade-offs, the shape adapts accordingly. That's what mature engineering actually looks like in practice, not a single rigid answer applied everywhere, but the best available solution for each problem as it actually exists. 5 problems. Pressure, liquid surge, rollover risk, weight, cleanability. One shape that addresses all of them simultaneously more efficiently than any alternative engineers have tested across a century of trying. The answer was always round. Physics just had to keep proving it until nobody argued anymore.